Hello everyone. In previous section, we have seen rational numbers on the number line. Today, we'll see irrational numbers. First of all, what are irrational numbers? A number S, which is called irrational if it cannot be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. As we have seen, there are infinite many rational numbers. Same applies for irrational numbers even. There are infinitely many irrational numbers too. Now, what do you mean by irrational? With example, we'll understand. Numbers after decimal point are non-terminating and non-repeating. Both the condition should satisfy. Here examples are √2, √3, √5 and so on. Why √4 not? Because √4 is a perfect square. Okay, perfect square of 2. Again, we'll see the classification of real numbers. Real numbers can be rational numbers or irrational numbers. Rational numbers, the examples are, it can be any negative integer, 0, positive integer, any number which can be have the form of P by Q. Square root of 4, as we have seen, this is a rational number, not an irrational number. 1.1515 and so on. Here the decimal, after decimal the numbers are repeating. Here 1.01, the number after decimal is getting terminated. So this is rational. Now irrational example, it can be 1.0111110 and so on. Not terminating even and no repetition of the numbers after decimal. √3 and √5 and so on. Even the pi, that is also irrational number. These are the examples of rational and irrational. Now we'll see that every real number can be represented with the point on this number line. In previous section we have plot a rational number, and also every point on the number line represents a unique real number. Now if this is a number line, then any point on this number will be a real number. Now we will see example number 3 from your textbook, that is locate √2 on the number line. Now √2 is a irrational number. How you are going to locate √2? We'll see in this section. First of all, draw a number line. Make partition with 1 unit for each points. Here I am taking roughly, you can use scale for this. I have assumed that this is 1 unit distance. 1 unit distance. Now I am pointing this point as 0 and number 1 with A. Now draw a 1 unit, same 1 unit line perpendicular to point A on the number line. Perpendicular means the line is making 90-degree angle on the number line. Now I will label this point with B. Now I will join this triangle. After this, we'll just first analyze this diagram. What we have did? We have labeled 0 with O and 1 with A. So we are having OA is equal to 1 unit. AB is equal to 1 unit. And join OB. AB is perpendicular to OA. Now, can you see all these characteristics are here, and we have to find out this particular length. Which theorem we are going to apply? We are going to apply Pythagoras Theorem. Why you want to apply Pythagoras Theorem? First we will find out this distance. What will be the equation for Pythagoras Theorem over here? Here the hypotenuse is OB square is equal to OA square plus AB square. Here OA is 1 unit plus AB is 1 unit. Therefore 1 plus 1. Therefore you will be having 2. So OB square is equal to 2. What will be OB? The square root will go over here. The square will go to the next side. It will become square root of 2. Therefore, this hypotenuse length will be root 2 unit. After this, what you are going to do? You are going to take a compass and then you are just going to keep the compass at the point of 0, and then you are just going to drag this point on the number line and pointing this number as P. So this distance is nothing else but root 2. So this point will be your root 2 on the number line. So here the steps. Once again I will analyze the steps for plotting root 2 on the number line. You are going to draw a number line. You are going to take 1 unit distance for each of the points on the number line. Here I have mentioned the points, and here I have drawn the number line roughly. So here you are going to take 0 as O, 1 as A. This is 1 unit. Now you are going to draw a line perpendicular which is of 1 unit to the point A. Therefore AB is perpendicular to OA and then what you are going to do, you are going to join OB. Now this triangle is right angle triangle, so you are going to apply Pythagoras theorem, and then doing this calculating OB, you will get root 2. So you are going to write root 2 distance over this hypotenuse. You are going to use compass, and then you are going to drag this point on the number line, and this point will be called as root 2. Okay, now we'll see example number 4. You are going to locate root 3 on the number line. For this example, you will need to find first of all root 2 on the number line. We'll see it from starting. Once again, I am drawing the number line, taking 0, 1, 2, 3, -1, -2. I have taken these numbers at 1 unit distance each. Now, before plotting the numbers, we'll first discuss one method for finding the numbers after root 2. If you are given m, then first you will have to find m minus 1 on the number line. That means if you have given root 3, first you will plot root 3 minus 1, that is root 2 on number line. Now we'll follow the steps for plotting root 2. Again, here I am going to point this point as 0, taking this as A. This is 1 unit distance. Now I am going to again draw a same 1 unit distance line over here, 1 unit which is perpendicular. Okay, labeling this point as B. I'll find out this is root 2. Taking the help of compass, I'll draw an arc on the number line. This is root 2 on the number line. Now what I have to do, I will draw a straight line over here of 1 unit distance again, but this line will be perpendicular on point root 2, which I have named as X. Again, what you are going to do, you are going to join this O. I'll label this name with C. So I'll join OC. You take help of scale. I'll join OC. Taking the help of compass, what I will do, I'll drop this point over this. But before that, what I will do, I'll explain how this root 3 comes. Analyzing the figure for root 3, we are going to analyze it. XC, it is 1 unit. Now what will be OX? It is root 2. OX is equal to root 2. And you have to find OC. But before that, we'll see which kind of triangle it is. Obviously it is perpendicular, So right angle triangle. So CX is perpendicular to OX. Therefore, applying Pythagoras theorem, OC square is equal to OX square plus CX square. XC square. XC square is OX is equal to root 2 square plus XC is 1 unit, 1 square. So here root 2, so that is nothing else but 2 raised to 1 upon 2. So this will be cancelled. This we are going to study further. Plus 1. Therefore here it is 2 plus 1, that is 3. So OC square is equal to 3. So what will be OC? OC will be square root of 3. And what you have to plot? Square root of 3. So what will be the length of this hypotenuse? Root 3. So taking the help of compass, you can draw a arc over here on the number line, and this will be root 3. Okay, now we'll start with exercise 1.2 of your chapter 1 number system. First question is true or false, and then you have to justify it. The first statement is every irrational number is a real number. Here simple, real numbers are rational or it can be irrational. Therefore the answer will be true. Yes, every irrational number are real, because real number is collection of rational numbers plus irrational numbers. Now we'll see the second statement. Every point on the number line is of the form square root of m, where m is a natural number. Here obviously the number line is not having the form of square root of m. Why? Because no negative number can be the square root of any natural number. So the statement is false. Now we'll see third statement. Every real number is an irrational number. As we have seen first example, real numbers are rational and irrational. Irrational example can be root 3, root 5, root 6 and so on. Is root 4 a rational? Yes, it's rational. Why? Because it is a perfect square. Therefore, yes, every irrational numbers can be real number, but every real numbers are not irrational numbers. Here we'll see the second question. Are the square root of all positive integer irrational? If not, give an example of the square root of number is a rational number. Last statement we have seen. So the example for this we'll see first. Square root of 3, no. Yes, it is irrational. Square root of 4, yes, it is rational. So Here the answer will be no. The answer will be no. Why? Because square root of 4 is 2, which is rational. So always give example for such questions. Now the third question is, show how root 5 can be represented on the number line. First of all, what you are going to do, here I'll show you with the scale. First of all, draw a number line. Again, take 1 unit distance for the points on the number line. Here I have taken 1 unit is equal to 2 centimeter. So the distance is this much. 0, 1, 2, 3, minus 1, minus 2. First of all, for root 5, what you will have to do? You will have to find 5 minus 1. Therefore, you will have to find first of all this square root of 4. Okay. Then what you are going to do? Now square root of 4 is what? 2. Okay. So what you will do? You got that the first point to be plotted on the number line is 2. Then I'll draw a perpendicular line of 1 unit distance on 2. This is right angle. Labeling this point as OA and this point as B. What we'll do? We'll join this line. What is this distance? 2 units. What's this distance? Okay. Again, we'll analyze the figure. OA is equal to 2 units. That means this. AB is equal to 1 unit. Join OB, where AB is perpendicular to OA. Therefore, the triangle OAB is right angle triangle. By Pythagoras theorem, you have to find OB. What will be OB? OB square is equal to AB square plus OA square. Therefore, AB is 1 unit, 1 square. OA is 2. So here it will be 2 square. What will be the answer? 1 plus 2 square means 2 into 2. 2 times 2. It will be 4. What will be the answer over here? 5. So OB square is this. What will be OB? OB will be square root of 5. So this is square root of 5 units. So this distance is 5 square root of 5 units. What you have to do now? you have to take the compass, point at 0 and B. Now draw an arc on the number line. So this point is called as your root 5. If you will follow these steps, any irrational number is easy to plot on the number line. Your fourth question is classroom activity. So that will be done in your classes. Hope you have understand each of the questions and their answers. If you like the video, please do like, share and subscribe. Thank you. Have a nice day.